How to abstract. This document is an introductory tutorial to using regular expressions in Python with the RE module. It provides a gentler introduction than the corresponding section in the library reference. Introduction. Regular expressions called REs or regex or regex patterns are essentially a tiny and highly specialized programming language embedded inside Python and made available through the RE module. Using this little language, you specify the rules for the set of possible strings that you want to match. This set might contain English sentences or email addresses or text commands or anything you like. You can then ask questions such as, does this string match the pattern, or is there a match for the pattern anywhere in this string? You can also use REs to modify a string or to split it apart in various ways. Regular expression patterns are compiled into a series of bytecodes which are then executed by a matching engine written in C. For advanced use, it may be necessary to pay careful attention to how the engine will execute a given RE and write the RE regular expression in a certain way in order to produce bytecode that runs faster. Optimization is not covered in this document because it requires that you have a good understanding of the matching engine's internals. Regular expression language is relatively small and restricted, so not all possible string processing tasks can be done using regular expressions. There are also tasks that can be done with regular expression, but the expressions turn out to be very complicated. In these cases, you may be better off writing Python code to do processing. While Python code will be slower than an elaborate regular expression, it will also probably be more understandable. Simple patterns. We will start by learning about the simplest possible regular expressions since regular expressions are used to operate on strings. We will begin with the most common task, matching characters. For a detailed explanation of the computer science underlying regular expressions, deterministic and non-deterministic finite automata, you can refer to almost any textbooks on writing compilers. Matching characters. Most letters and characters will simply match themselves. For example, the regular expression test will match the string test exactly. You can enable a case insensitive mode that would let this RE match test or test as well. More about this later. There are exceptions to this rule. Some characters are special meta characters that don't match themselves. Instead, they signal that some out of the ordinary thing should be matched, or they affect other portions of the REs by repeating them or changing their meaning. Much of this documentation is devoted to discussing various meta characters and what they do. Here is a complete list of the meta characters. Their meanings will be discussed in the rest of this how to. Dot, caret, dollar, asterisk, plus, question mark, open curly brace, close curly brace, open square bracket, close square bracket, backslash, or pipe, open parenthesis, close parenthesis. The first meta characters we will look at are square bracket, open and close square bracket. They are used to specifying a character class, which is a set of characters that you wish to match. Characters can be listed individually, or a range of characters can be indicated by giving two characters and separating them by a hyphen. For example, A, B, C will match any of the characters A, B, or C. This is the same as A to C, which uses a range to express the same set of characters. If you wanted to match only lowercase letters, your RE would be A to Z. Meta characters except backslash are not active inside classes. For example, AKM dollar will match any of the characters AKM or dollar. Dollar is usually a meta character, but inside a character class, it's stripped of its special nature. You can match the characters not listed within the class by complementing the set. This is indicated by including a caret as the first character of the class. For example, caret 5 will match any character except 5 if the caret appears elsewhere in a character class. It does not have special meaning. For example, uh, in square bracket 5 caret will match either a 5 or caret. Let's do some example. Okay, import re module, then re dot match pattern. So let's do the pattern a b c, and then string, any string, let's say hello a hello abc xyz. Match object if m is not none. If m print match found, else print match not found. Print m dot groups, print m dot group 0, match not found, right? So match not find, right? And if I say your star, any character star, and if I say any character star, then match will be found. Why? Oh, this one. Match found. Hello ABC. Right. And m dot re print your regular expression was format, that was me.re printf, the string to be matched against was format m dot string. Print here, there is one. Okay. And then okay, use of caret, if I say like this, match at the start of the string, So match not found. Non-type object has no attribute. Where line number 16. If and then match not found. Okay. And if I say like this, I say this, match found. Hello X. And if I use grouping, like this, then colon x y z. Why is not hello? So except ABC. ABC will not match. Okay. This will return H only. Why not? Oh, at the first. Okay, match all. So if I say find all, then it will result okay. Then this should be len and dot len m 11 1 2 3 4 print m. This will not work in this case because it returns list. Right, here we can see ABC will not match. And if I say like this, so ABC will match. ABC exactly. Thank you. Okay, so perhaps the most important meta character is the backslash. Backslash, as in Python string literals, the backslash can be followed by various characters to signal various special sequences. It is also used to escape all the meta characters so you can still match them in patterns. For example, if you need to match square bracket or backslash, you can precede them with a backslash or a backslash to remove their special meaning. For example, if I want to match open curly brace and close curly square bracket, so directly it will not allow. regular expression. Now it will allow, and if I place like this, this, so and run it, it will match like find all two, right? Let's use match instead of that. So if I say this, it will not found match because of, so we have to use star slash comma star slash. Let's see. Match found. Length of m, yeah, this is not valid now. Now we have to use m dot groups and print m dot group for group in m dot groups. Print g dot print g. Match found. Match found. So and for find all, let's do the find all example. Print find all example. format underscore titles. Now it will print, right? Okay. So let's use format underscore titles. So here find all. So here this will not work. Instead we have to say, because it returns list, and then for g in g and g, and is equal to empty string, and that's it. Right. Okay. Now some of the special sequences begin with backslash, represent predefined set of characters that are often useful, such as the set of digits, the set of letters, or the set of anything that is not white space. Let's take an example of backslash w matches any alphanumeric character. If the regular expression pattern is expressed in bytes, this is equivalent to the class A to Z small, A to Z capital 0 to 9 and underscore. If the regular expression pattern is a string, backslash word will match all the characters marked as letters in the Unicode database provided by the Unicode data module. You can use the more restricted definition of backslash w in a string pattern by supplying the re.ascii flag when compiling the regular expression. So for example, let's do here backslash w. So it means it will match word, and let's do like this. We do not need this one. Match groups. So here we can see w word. There is some w word. Okay, this is not correct. W plus w plus only matching O. Okay, it should be like this. Why it is not matching? I think the program, let me do it, comment out code, comment, online comment, and then comment out this as well. So w whole word match not found. Match not. Why? Alphanumeric. let's see. Okay, if I use this one, for example, let's do this one, replace this one, and here plus one more. Hello, match found. And if I say sort, use shorthand operator, this one output should be the same. What was the miss? Oh, got it. This plus sign was outside this, that's why it was not working and only matching single letter. Okay, I got it. So, okay. And then if I say space this, it will match both of them, ABC, right? Because this square bracket is not part of it. So if I remove it like this, it will match ABC. Hello, ABC. And is equal to space, run it. Hello, ABC, right? The following list of special sequence is not complete. For a complete list of sequences and expanded class definitions for Unicode string patterns, see the last part of regular expression syntax in the standard library reference. In general, in Unicode versions, match any character that is in the appropriate category in the Unicode database. Backslash D matches any decimal digit. This is equivalent to the class 09. Backslash D matches any non-digit characters. For example, let's use it. For example, let's use it like digit. So this will match any digit, and then this will match so here is 1 2 3 4 5 6 and A B C E, like this. Match not found. Oh, due to this exclamation sign. So let's D plus again. Okay, backslash capital D plus. This time match not found. Why? Plus. This should be third word, then it will match found, right? So match any non-digit character. This is equivalent to the class caret 0 to 9. Backslash s matches any space white space character. This is equivalent to the class backslash t space backslash t backslash n backslash r backslash f backslash v. Backslash capital S match any non-white space character. This is equivalent to the class caret space backslash t backslash n backslash r backslash f backslash v. Backslash w matches any alphanumeric character. This is equivalent to the class a to z capital 0 to 9 underscore. Backslash w matches any non-alphanumeric character. This is equivalent to the class caret a to z capital caret a to z 0 to 9 underscore. These sequences can be included inside a character class. For example, backslash s comma dot is a character class that will match any white space character or comma and or dot. The final meta character in this section is dot. It matches anything except a new line character. And there is an alternate mode re dot dot all where it will match even a new line. Dot is often used where you want to match any character. So if I so okay, repeated things. Being able to match varying sets of characters is the first thing regular expressions can do that is not already possible with the methods available on strings. However, if that was the only additional capability of regular expressions, they would not be much of an advance. Another capability is that you can specify that portion of the regular expression must be repeated a certain number of times. The first meta character for repeating things that we will look at is star. Star doesn't match the literal character star. Instead, it specifies that the previous characters can be matched 0 or more times instead of exactly once. For example, CA star T will match CT 0 A characters, CAT cat 1A, CAAT 3A characters, and so forth. Repetition, such as star or greedy. When repeating a regular expression, the matching engine will try to repeat it as many times as possible. If later portion of the pattern don't match, the matching engine will then back up and try again with fewer repetitions. A step by step example will make this more obvious. Let's consider the expression A in bracket B C D close square bracket star B. Um, this matches the letter A, 0 or more letters from the class B C D, and finally ends with a B. Now imagine matching this RE against the string ABCD. Step matched expression 1. A. The A in the RE matches B, A, B, C, D, C, B, D. The engine matches B, C, D going as far as it can, which is to the end of the string. 3. Failure. The engine tries to match B, but the current position is at the end of the string, so it fails. 4. A, B, C, D. Backup so that B, C, D star matches the one less character. Failure. Try B again, but the current position is at the last character, which is D, and ABC. BCD. Back up again so that BCD star is only matching BC. Try B again. This time the character at the current position is B, so it succeeds. The end of RE has now been reached and it has matched ABCD. This demonstrates how the matching engine goes as far as it can at first, and if no match is found, it will then progressively back up and retry the rest of the RE again and again. It will back up until it has tried 0 matches for BCD star, and if that subsequently fails, the engine will conclude that the string doesn't matches for BCD star, and if that successfully fails, the engine will conclude that the string doesn't match the RE at all. Another repeating meta character is plus, which matches one or more times. Pay careful attention to the difference between star and plus. A star matches 0 or more times, so whatever is being repeated may not be present at all, while plus requires at least one occurrence. To use a similar example, CA plus T will match CAT 1A, CAAT 3S, but won't match CT because their A is 0. There are two more repeating operations or quantifiers. The question mark character question mark matches either once or 0 times. You can think of it as marking something as being optional. For example, home hyphen a question mark brew matches either home brew or home brew. So let's do some examples. So let me remove this. So if I say here character class string, character class word match 0 or more, if I say pass empty string, what is that? Okay, this one is unbounded, right? Done. Match found, and that matches this one. If I say plus, so it will try to match exactly once, and match not found. If I say a, it will match because there is at least one letter, that is the minimum requirement. Okay, and then there are more repeating quantifiers. Okay, let's try the example of this one. For example, then home question mark, home question mark, home whether it is there or not, home brew. And if I say home brew, then home brew match found, AB home brew. And if I say this will match present or not, home brew as well. And if I say this, it will not match. The most complicated quantifier is mn, where m and n are decimal integers. This quantifier means there must be at least m repetitions, and the most n. For example, a slash 1 3 b will match a slash b, a slash b, a slash b. It won't match ab, which has no slashes. Let's see the example of this. For example, slash a slash repeating times is 1 2 3 1 2 3 b. So if I provide a slash b, it will match because one time. If I say this, it will match two times. For two times, three times it will match, but it will not match for four times. And if I remove this, it will also not match. And if I say a slash b, it will match. You can omit either m or n. In that case, a reasonable value is assumed for the missing value. Omitting m is interpreted as a lower limit of 0, while omitting n results in an upper bound of infinity. The simplest case m matches the preceding item exactly m times. For example, 2 will only match this. Let's see the example. If I remove this, so it will exactly match one time. Or if I place 2, it will exactly match two times. In this case, it will match not found because here there is single slash character is present. If I place 2, it will match again. Readers of the reductionist band may notice that the three other quantifiers can all be expressed using the notation 0 comma this is the same as star, and 1 comma this is equivalent to plus, and 0 comma 1 is the same as 0 comma 1 is the same as question mark. It is better to use star, plus, or question mark when you can, simply because they are shorter and easier to read using regular expressions. Now that we have looked at the some simple regular expression, how do we actually use them in Python? The RE module provides an interface to the regular expression engine, allowing you to compile REs into objects and then perform matches with them. Compiling regular expressions. Regular expressions are compiled into pattern objects which have methods for various operations such as searching for pattern matches or performing string substitutions. Import RE. P is equal to RE.compile P. RE.compile this. RE.compile also accepts an optional flags argument used to enable various special features and syntax variation. We will go over the variable settings later, but for now a single example will do. P is equal to RE.compile AB star RE.ignore case. The RE is passed to RE.compile as a string. REs are handled as a string because regular expressions are not part of the core Python language and no special syntax was created for expressing them. There are applications that don't need REs at all, so there is no need to bloat the language specification by including them. Instead, the RE module is simply a C extension module included with Python, just like the socket or zlib modules. Putting REs in strings keeps the Python language simpler, but has one disadvantage, which is the topic of the next section: the backslash flag. As stated earlier, regular expressions use the backslash character backslash to indicate special forms or to allow special characters to be used without invoking their special meaning. This conflicts with the Python's usage of the same character for the same purpose in string literals. Let's say you want to write a RE that matches the string backslash section, which might be found in a latex file. To figure out what to write in the program code, start with the desired string to be matched. Next, you must escape any backslashes and other meta characters by preceding them with a backslash, resulting in a string backslash backslash section. The resulting string that must be passed to RE.compile must be slash slash backslash backslash section. However, to express this as a Python string literal, both backslashes must be escaped again. Backslash section, text string to be matched, backslash backslash section, escaped backslash to RE compile, backslash 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 section, escaped backslashes for a string literal. In short, to match a literal backslash, one has to write backslash 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 as a RE string, because the regular expression must be backslash backslash, and each backslash must be expressed as backslash backslash inside a regular Python string literal. In REs that feature backslashes repeatedly, this leads to lots of repeated backslashes and make the resulting strings difficult to understand. The solution is to use Python's row string notation for regular expression. Backslashes are not handled to any special way in a string literal prefixed with R. So R backslash n is two character string containing backslash and n, while backslash n is a one character string containing a new line. Regular expressions will often be written in Python code using this row string notation. In addition, special escape sequences that are valid in regular expressions but not valid as Python string literals now result in deprecation warning and will eventually become a syntax error, which means the sequences will be invalid if row string notation or escaping the backslashes is not used. Regular string, row string, AB star, R AB star, backslash 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 section, R backslash backslash section, backslash backslash W plus backslash backslash S plus backslash backslash 1. Regular string, R backslash W plus backslash S plus backslash 1. Thank you.